All right, today we have maybe the easiest lesson and the fastest lesson that I've taught all year long.
Are you lying?
No, I don't. That is not a statement I make all the time.
Easier than the last week we just did? That was super easy.
No joke. This will be this will be really simple. It's basically two things, and then like your homework. It's probably one of the biggest assignments I've given you as far as the problems. You're going to do 21 of them.
Oh my God.
It's going to take 4 minutes. It'll take 4 minutes.
But it's only one question?
Yes.
No, we had a conversation already. I wasn't telling. I was saying that's weird.
Remember that, it's going to take you 5 minutes. Alright, so first, you got to have your calculator, okay? Because you're going to need that in a minute. Second, the very first lesson I taught you guys when we came back from Christmas break was about these things called inverses. Y'all remember inverses?
No.
Yes. They're inverses, right? Where basically they did the opposite of each other. And we said that we actually had 4 things that we talked about. How we could recognize whether something had an inverse. Then, of course, how to write an inverse. And then, of course, graphing it, how you could tell that they were inverses. Well, what we're talking about today, they are inverses of one another, okay? There's a connection between the two that you have to be familiar with, all right? We're talking about this thing called logarithms today. And logarithms are just another way of writing an exponent. So if it's another way of writing an exponent, why would I need it? Well, here's why. If I ever have an exponential equation that I can't solve, guess what I can do, and then I can solve it. I could rewrite it as what I say it was connected to. What's the inverse of an exponential equation? A logarithmic one. So if I have an exponential equation I can't solve, I could rewrite it as a logarithm, and then I would be able to solve it. Well, what if I have a logarithmic equation I can't solve? Y'all with me yet? If I have a logarithmic equation I can't solve, what can I do with it? I could rewrite it as a exponential equation, and then I'd be able to solve it. They're connected. Okay? So, in order for me to understand the connection, it's all about one thing. Okay? One thing. And it's an old song that I'm going to refer to today. Here's how we would state this. Log base b of a equals x. You do it. Log. Don't say b. Log base b of a equals x. Now without me.
Log base b of a equals x.
Okay, you know how to read it then. All right, here's the thing. Remember that song? It's all about that. What was that? That's the key. I'm not going to sing it, and I'm not going to say it again. The base is the trigger. You understand? If I want to take a logarithm and I want to rewrite it as an exponential equation, that base is my trigger. Okay? So if I was taking log base b of a equals x and I'm rewriting it as an exponent, the base of my log b becomes the base of my exponent. That's the trigger. That's the key. Then you do a loop. Base b, okay, and then we write it as b to what power? B to the x power will equal what? A. That's the connection between logarithms and exponents. So whether I'm going logarithms to exponents or exponents to logarithms, what's the trigger? Huh? What do we call it? The base. The base is the trigger. Okay? The base of my log becomes the base of my exponent. If I were going the opposite direction, the base of my exponent becomes the, hello? The base of my exponent becomes the base of my log. Okay, that's the trigger. Once you do that, you follow the loop, and this is cake. Okay, seriously, watch. How would I rewrite log base 3 of 9 equals 2? 3 squared equals 9. Is that a true statement?
Yes.
Of course it is. That's just proof that we wrote it right. Log base 3 of 9 does equal 2, and 3 squared does equal 9. Okay, there's the connection. Are y'all with me? Did you shake your head no?
Yeah.
Are you for real or are you just being...
Keep going.
Okay. Number 2. What's the trigger? 6, right? The base of the log becomes the base of my exponent. And then we follow the loop. 6 to what power? Third power equals 216. Done. That's it. Number 3. How would I rewrite this logarithm as an exponent? 7 to the 0 power equals 1. That's a true statement, isn't it? Anything to the 0 power is 1. We talked about that. Remember, so one time it's on top of itself, 7 over 7, 1. Number 4, how would I rewrite that? 2 to the 4th power equals 16. There's a connection between logarithms and exponents. Look at number 5. How would I rewrite it? 4 to the negative 2nd power equals 1 over 16.
What happens if they don't equal?
It does. They're connected because it does.
Okay.
It'll
Okay.
always equals.
Yeah, because it is what it is. I mean, and if it can be written that way as a logarithm, then it can be written that way as an exponent. It has to be equal. Okay, there's not like a, well, sometimes will it not? No, it has to be. If it can be written as a logarithm that way, then it can be written as an exponent that way. Does that make sense? There's no other way around that. If it is true one way, it has to be true the other way. The only way it wouldn't is if you wrote it wrong. But if it's true one way, it has to be true the other. Okay? No exceptions. Number 6, how would we write it?
9 to the 3 over 2 power equals 27.
Absolutely true. Okay? Type it in. It's absolutely true. Now, when we go back the opposite direction, again, without sounding like an idiot, it's all about the what? It's all about the base, right? The base of my exponent becomes what? The base of my log, right? So if I were rewriting 14 squared equals 196, what's the base of that exponent?
14.
So it becomes the base of your log. Log base 14, and then again, we follow the loop, right? Log base 14 of what?
196.
Equals what?
Equals 2.
And there it is. That's absolutely true. Log base 14 of 196 would equal 2. Okay? This is where second period thought there was some trick. There's no trick. This is it. I mean, it's this easy. You just have to know the connection between logarithms and exponents. And again, I told you why, but we're going to do that on this week, Friday. If I can't solve a logarithm, what can I do? I can rewrite it as an exponent and then solve. If I can't solve an exponent, then I can what? Rewrite it as a logarithm and solve. They're connected. So if I can't solve one, I can solve the other. How do I rewrite number 8? Log base 3 of 81 equals 4. It's this easy, guys. Number 9. Log base of equals, and that's something else we're going to talk about. I want you to notice here. When your base of your logarithm and the argument of your logarithm are the same, what will always be the result? 1. Log base 7 of 7. Guess what it would be? 1. Log base 9 of 9. Guess what it'll be? 1. So that's not a coincidence. That's the way it'll always be. Okay? Number 10. How do I rewrite it? Log base 36 of equals done. Okay? Number 11. Log base 2 of 1/8 equals -3. Done. Last one. Log base of equals. Okay. Any questions with taking a logarithm and writing it as an exponent, or taking an exponent and writing it as a logarithm?
No.
No tricks. It's easy stuff. Now, grab your calculator real quick as we go to the back. We're going to mark the bottom of these note sheet out. The change of base formula is something that we don't need anymore. Back in the Stone Ages, when I learned this, I had to have it. But you don't have to have it anymore. I'll explain.
Funny how that works.
Okay, so look at the front of your calculator. Do you see the button that says literally LOG?
Log.
Yeah, it just says log. All right, push it real quick. And let's go ahead and do number 15. Notice how it just says log of 100? Okay, don't yell out the answer. Let me just explain something real quickly. Huh? You could push catalog, but that's silly. The LOG button's right on the front of your calculator. It's like underneath the square root, isn't it?
Oh, yeah, never mind.
It just says log. All right, so do number 15. Just type in log of 100. I'll tell you the answer. You'll know the answer in about 2 seconds. Anyways, listen. Let me explain something real quick. When it comes to that button being on your calculator, there were certain values that were being used so often with exponents and with logarithms, they decided to make a button on your calculator. And that button on your calculator, when you type log, is using base 10. Okay? So like the notes say on your paper, they call base 10 common log. So when you type the log button in your calculator, it's technically doing log base 10 of whatever the value you just plugged in there. So whenever in the future you see just log of x, it's understood to be base what? It's understood to be base 10. Now look at all the other problems besides number 15. Are they all base 10? So back in the day, when I was your age, we had to use that thing on the bottom, change of base formula, to solve all the problems that were not base 10. But you don't have to do that anymore. Okay? I'm going to show you in your calculator how you're going to do it. And we're going to start with number 15 to make sure you understand. This was understood to be base 10, correct? So here's the thing. In the future, you're going to mindlessly type these into your calculator. Okay? I get that. You will. But I want you to understand exactly what you're doing, what you're finding when you mindlessly type log of 100 in your calculator. You are finding the answer to this question. 10 to what power equals 100? See, that's what you're doing. 10 to what power, and that means it would be a question mark, equals 100. So the log base 10 of 100, or log of 100, what did y'all get when you typed it in there? 2. 2 is the answer to log of 100. Why? Because 10 to the second power equals 100. You understand that? Go directly above it. You probably know where this button may be in your calculator right now or not. I don't care. I want you to think for a second. Using that logic, what's the answer of log base 7 of 49?
2.
It's 2. You all should know that. You should all be able to logically conclude that the answer to that problem is 2. Why? Because 7 to what power equals 49, right? That's what you're finding in a minute when you mindlessly type that into a calculator. I just want you guys to be aware of the logic there. That way, if you type something in wrong, or you'll understand what you're getting. Y'all understand that? Okay, let's do one more in our brain. What do you think the log base 3 of 27 equals? It equals 3. Now, if you didn't logic that in your own brain, one more time, let me tell you. 3 to what power would give me 27? The third power. Think about it. 3 times 3 is 9 times 3. There it is. 3 to the third power equals 27. Now, in the future, you're not going to think that way. In the future, you're going to go to your calculator because there's a button that actually will allow you to use whatever base you want. You don't have to use base 10. And therefore, you don't have to use the change of base formula that I had to use when I was your age. So here's where you go in your calculator. Ready? You go to alpha window number 5. Alpha window number 5 allows you to change the base. See, you don't use the button on the front of your calculator. That's base 10. But for all these other problems besides 15, those aren't base 10. They're base something else. So we use alpha window number 5. Where do you go? So, of course, I can go through and I can answer all these questions using alpha window number 5. Now, it'd be a waste of time to use alpha window number 5 on number 15 because it's base 10. If it's base 10, use the log button. But for example, number 16, log base 12 of 1 equals what? Well, 12 to the 0 power equals 1. So there it is. That is what you're finding when you go type these in your calculator. So help me out. Do number 17 through 20 with me. Alpha window number 5. Log base 2 of 64 equals what? 6. What does that mean? 2 to the
6th power
equals. Y'all understand what you're finding when you type that into your calculator. Okay? How about number 18? Log base 3 of 243. 3 to the 5th power equals 243. Y'all understand?
Yes.
Okay, number 19. Type it in your calculator. 9 to the negative 2nd equals 1 over 81, which should make sense to you guys, because we talked about how if you raise something to a negative exponent, you change its location. So that 9 goes to the bottom, changes that to squared. So 1 over 9 squared, 1 over 81. There it is. And last one, log base 64 of 4. 0.3 repeating. I would love it if your calculator will change those to fractions. What is 0.3 repeating as a fraction? Y'all know how to do it in your calculator if you can't remember that? Alpha, y equals number 4. Now you're going to have some today and some in the next couple of days where you'll type those alpha window number 5s and you're going to come up with decimals that won't be changed back to fractions, and that's okay. In fact, the last 4 on tonight's homework assignment, you won't be able to change those back to fractions. It's okay. You're just going to write the decimal answer. I would prefer that you round to 2 or 3 decimals. Don't round to 1. I prefer 2 or 3. When you have to round decimals, round to 2 or 3. So, questions? So like I said, you're going to have 21 problems. The first 3 are rewriting a logarithm as an exponent. The next 3 are rewriting an exponent as a logarithm. Then you're going to have 15 straight problems where you're simply typing them into your calculator. Alpha window number 5. So how long do you think this might take?
5 minutes.
I'd say 4. Why did you mock me like that?
Because I can. Because you mocked me earlier.
Shut up. You made me mess up. I just did it again. Okay, 2. Y'all will be done with this homework seriously within 5 minutes. Easy homework.
All of them.
Brayden, I'm actually mad that you didn't ask me that question.
I was kidding. I was saying you do.
Of course, all 21. It'll take you less than 5 minutes. Look, I just passed them out. Caitlin's already on number 4. Okay, you should be done with that in less than 5 minutes. If you're not, we're making fun of you.